couple is of couples, forces forming couples is what we're going to see in this lesson. So let us start by defining a couple and then we shall see the details. A couple, this is formed by two parallel opposite forces of equal magnitude whose lines of action don't meet. Forces forming a couple don't yield a resultant force but produce a resultant moment. Okay. You see, when I go studies, I'm going to be having this as a force and this as a force. So when these forces they don't yield any resultant, so in simple terms, they are balancing here. But if I apply certain force here and then this comes like this, so this can't be a couple. So to form a couple, these forces should be balancing as you see. Even if it's like this, they should be balancing. Whether they act also like this, they should be balancing. So they are equal. But now, it means that if these forces are equal, it means that their resultant is zero. Now, what happens if their resultant is zero? It means that this force is their opposite. So meaning their directions are opposite one another. So this is equaling to this, it means that the resultant is going to be zero. So all of them are vertical. They can be when all of them are horizontal. So don't take it that always they are horizontal. They are vertical. So they can be horizontal. Now, if their resultant is zero, it doesn't mean that even their sum of moments is zero. So these ones, for them to form a couple, they should be having resultant as zero, but their moments is not zero, as you are going to see. So the moment of a couple, consider two forces each of magnitude F as shown below. So you have this, you have it at point A, we have also point B, we have also point C. Now, if we take moments about A, you see, if I take moments about A, you see that this one, first of all, is going to be zero because F times zero is going to be zero. Okay, let me also add that. Then, when I take moments about A, you see that this is going to be, this first is going to be F, this is going to be clockwise F, then plus this 2 to get the perpendicular distance from this point. Then plus another F, this one, then times I0. Because it's at the point where that is out, this force has a point at its line of action, that's why it's 0. When you add this, it's going to be 0, then this is going to be that. So we are taking moments at A. Then take moments at B. If I come at B, you see now I will say this one first of all is going to act. You see, when I have this, all of them are going to be clockwise. This one is going to be clockwise, and even this one is going to be clockwise. So when I take moments about B clockwise, you see that the sun is going to be, I get this times x, its perpendicular distance from this point is x, then times the force, then plus, even this is clockwise, I get x times this, y times this. As you see there, you see this is common, when I factorize it out, I get that clockwise. When I take moments about to see now, you see that now I'm going to be having f, this perpendicular distance is going to be x plus y, so I get f times x plus y, then plus the other f times 0. I was not going to get that because you see this one, when I consider now this force here, you see this point where we're taking moments is in the right over to this force. That's why it's going to be 0. So when I'm here, there's no perpendicular distance. So the perpendicular distance is 0 as we saw. So that's what we have there. Now, you note that I'm taking moments at A, B, and C, but all of them are giving me the same answer. Look at this, and also look at this. What does it imply? It implies that moments of the couple is the same about all the points in the plane of forces forming a couple. So when you have a couple, whatever point, wherever you take a moment from, the answer is going to be the same. In simple terms, the magnitude of the moment you get is going to be the same. Whether you take at A, whether you take at B, whether you take at as you see, it's going to be the same. So when you have a couple, you can take moments anyway you feel like. Okay, another one is moments of a couple. Moment of a couple is equal to magnitude of one force times the perpendicular distance between the two forces. So you see this, If these forces, remember, forming a couple, these forces should be equal, but not in, but they are having opposite directions. But now what I do, you consider just one force and get you multiply with the perpendicular distance, or you multiply by the distance between the two. So this is F and this is F. What I do, you get F, then the distance between the two is X plus Y, and there in the answer will be easy. So when you have a couple, all you need to do, get the force, then times the distance between those two forces, if there are two. If a given system of forces reduced to a couple, then the resultant force is 0, but the moment produced is not 0, i.e. the resultant, the x component is always 0, then the y component is also 0, but the sum of moments is non-zero. Let us see this example here. Show that the system of forces in the diagram below form a couple, hence find the moment of the couple formed. So to show that it's a couple, it means that we need to not show that the resultant force is 0. It means that the x component of the resultant forces are 0, also the vertical forces are 0. Let us first resolve like this. Resolve like that, always we are going to be having our x. It's that we don't have any force acting in horizontal direction, so it's going to be 0. When we resolve vertically in that direction, our y is going to be, we have that, then plus this one is opposite to this direction, so I put negative 3, then plus and negative 2. And so this one is going to also give me what? A 0. So meaning my resultant, which is given by the horizontal component and the y component, is going to be 0, 0. So that my resultant is 0. Then you see, hence, forces form a couple. We said we only form a couple if the resultant force is 0. And so that when you get the magnitude of that, it's going to give you a 0. So hence find the moment, we get take our moment. We can take it at this point, we can take it at this point, we can take it at that point. All of them will yield the same answer as we've seen here. So let me take it at A, but let me take it, you can take it at A, you can take it at B, you can take it at N. So if I decide to take it here, it's okay. If I decide to take it here, it's okay, but you have to be careful. When I take it here, I'm going to say you can consider clockwise, you can consider anti-clockwise. So let me take it here, and let me consider anti-clockwise. So if I take it at A, this shows anti-clockwise. What do we have? Is that our sum is going to be, you see this one is, because we are talking at A, this one is going to be 3. There's no perpendicular distance, so the perpendicular distance is 0. Then plus. You see this one is the anti-clockwise, this force here. I think you can see when I put this here. When I take a moment there, it's going to be anti-clockwise. So it's going to be 5 times 4. Then you see when I take it here, you see this one is going to be anti-clockwise, and then it's going to be clockwise. So that's where I am going to attach a negative there. So then minus, this is going to be 2. Then times, add this, which will give us a 6. And you see that our sum is going to be 20 minus 12, which will be Newton meter. So that is the sum of moments. Even if you take it there, the answer is going to be the same. You try and see. If I take it at B and clockwise, all this is just an alternative trade, and the answers are going to be the same. If I take it at B, you see that now when I take it at B, is that this force is at B. So I'm going to be adding 5 times 0, then plus. At B, you see this one is going to be acting like that, and clockwise. So I'm going to be having 3 times this 4. Then minus, you see this one is going to be acting and clockwise. 2 times 2. The force is 2, perpendicular distance is 2, which will give us 8. Sorry, it's going to be 12 minus 4, which will be 8. newton meter. Whatever you take is going to be the same. So, as long as the result is 0, that implies that we have a couple. Moment is that the moment is not 0. The result is always 0, and the moment is not 0. That shows that we have a couple. So, these systems of forces, this and this and this, they reduce to couple. Why? Because this is 5. So it's 3 plus 2 is 5. So it means the resultant acting downwards is 5. The resultant acting upwards is also 5. So they will be having the resultant as 0. So that's it. That's for my examples. See you in the next lesson.